Hello everybody, my name is Archit Kamath, and the motive of this session is basically to address some doubts that were asked by students, some random doubts in the subject of control systems. Okay, what we have done is we have handpicked some of these doubts which are very trivial but not so trivial questions. Okay, they are a little different from what you conventionally get. Okay, and we have compiled this video. I promise you and I assure you that if you'll sit through this entire session, you will be able to definitely get some very useful information that will help you in the upcoming GATE exam. So please stay tuned for all the problems. So without wasting much time, because you are all busy preparing for the exam, let us get to the first question, that is on signal flow graph. Alright, this is on signal flow graph and they basically want us to find that overall transfer function using Mason's gain formula. Alright, why is it different? Obviously you are all used to getting this output over here. Alright, but the speciality of this particular problem is the output has come somewhere here, because of which some confusions, some complications may arise in some of the students' case. So let me start Mason's gain formula. Before I start Mason's gain formula, I would like to write down the formula for Mason's gain formula over here. Alright, so according to Mason's gain formula, if you want to find the transfer function C of S by R of S, alright, so the formula is feed forward gain. Okay, feed forward gain, all the feed forward, let us say there are F1, F2, F3, all of these are feed forward paths gains. So you will basically write it like this pattern, sigma. Okay, so you will sum it over I, say 1 to whatever number of feed forward paths that are there, Fi into delta I divided by delta. Now what is this delta and delta I? Let me tell you. Delta is basically a denominator wherein you are having a segregation of all the feedback loops, whether they are touching, single touching, double touching, so on and so forth. Alright, so if I want to expand this delta, it is going to be something like this. So this is the denominator I am going to expand, 1 minus sum of all the feedback loops, okay, sum of all feedback loops plus sum of feedback loops that are non-touching, like two non-touching feedback loops. Okay, so two non-touching feedback loops minus so on. So what will happen basically, if you want to continue like this, it will be 1 minus single loops, 2 non-touching loops, 3 non-touching loops, and alternatively plus minus plus minus plus minus plus, you have to keep doing. Alright, so this is the denominator. Once we get this, delta I is similar. What you have to do, you have to basically, it's the delta itself. It's just that suppose you are taking the first feed forward path, eliminate that feed forward path from the signal flow graph, and whatever delta you will get, that will be called delta 1. If you want for F2, eliminate F2 from that, associated with that you will get delta 2, which is nothing but the delta when F2 is missing from the signal flow graph. Alright, so I hope I have made the formula very clear. Once the formula is very clear, now let us try to find out all of these parameters. Basically the feed forward path, all the feedback paths, and all, let us see if there are 2 non-touching, 3 non-touching, how many ever loops are there, let us try to find out. Alright, so in this particular problem, before I get into solving it and trying to find all of those, my strategy is I always try to find number all the nodes. Why? Because with that I will be easily able to determine which of the loops are touching, which of the loops are not touching. So let me start numbering them. So from here I will start numbering this as 1, then 2, 3, 4, 5 and 6. Once I have numbered these, let me quickly start writing the feed forward gains and the feedback gains. Okay, so feed forward gains, gain, if you will see, let us see how many feed forward paths are there. Only one feed forward path, that is connecting R to S, that is nothing but 1, 2, 6, so that is 1. So it will be 1, 2, 6, and that gain is 1. Now feedback paths, okay, there are basically 3 feedback paths over here. 2, 3, 2 is one feedback path, 4, 5, 4 is one feedback path, 3, 4, 5, 3 is one more feedback path. Alright, so let us quickly write all of those 3 over here. So we have 2, 3, 2, associated gain is minus 2 by S. Okay, then we have 4, 5, 4. The associated gain is minus 3 by s. Okay, then you have one more, so I am just writing it onto the side so that it's more clear. So that is nothing but 3, 4, 5, 3. Okay, so 3, 4, 5, 3 is there. Now that gain is basically minus 24 by s, so minus 24 upon s. Alright, now basically what I have done, I was able to find my f1 and delta 1 will be the formula because only one feed forward path is there. To evaluate delta, I have all the single feedback paths. Now to see if how many touching loops are there, let me try to find a pair of non-touching loops, that is, okay, for fitting in the formula. Okay, so pair of non-touching loops in the sense, compare the numbers. Okay, if you see 2, 3, 2 and 4, 5, 4, none of the nodes are matching. So these two form a pair of non-touching loops. So I will just write it here, pair of non-touching loops. Okay, so that is nothing but 2, 3, 2, 4, 5, 4. So that will nothing be but 6 by s square. Alright, all the other loops are touching. If you will see 2, 3, 2 and 3, 4, 5, 3, 2, the 3 node is matching, because of which these two are touching. Once again, if by chance you will see 4, 5, 4 and 3, 4, 5, 3, these two are again touching because 4 and 5 are common in between them. Alright, so all of these components are ready with us. All we have to do is plug it into that particular thing and evaluate the final answer. So watch very carefully. Let me just draw a border so that nothing gets mixed. So what is it? I want f1 into delta 1. So f1 in the sense, f1 we already have the gain as 1, so that is done. So 1 into delta 1 is basically the delta when f1 is missing. In the sense, again I have to write it in the similar manner. So what I will do, I'll write 1 minus, okay, sum of all the feedback loops when f1 is missing. So if you remove f1, that means 1, 2, 6 is missing. In the sense, this particular feedback loop will get vanished. Only the 4, 5, 4 and 3, 4, 5, 3 will exist. So I have to add both of that and write it over there. And obviously this is negative, and one more negative sign is there. All of that together will form a plus. So you will have 27 by s. So you will have plus 27 over s divided by. Now the main delta, that is at the denominator, we have to basically do 1 minus of all of this will become plus because all of them are negative. So you have 1 plus 29 by s, then again plus, by default it is plus in the formula, and this is again positive, so 6 by s square. So you have 6 upon s square, and if you were to simplify all of this, you will get s plus 27 divided by s square plus 29s plus 6. So this is the overall transfer function. I know it seems a little complicated at first, but eventually after you solve, you get to know that it's the same procedure what you always follow. So let us now look at some more questions related to control system topics. Alright, so the second question of this series is from block diagram reduction. Basically, once again what they have done here is they have basically asked you to find the transfer function y by r. Alright, as to why I picked this is, I had got this as a doubt, and apparently some of them have tried to apply block diagram reduction and try to solve it, and they are landing at the wrong answer. So I decided to take this. Okay, see, just because you know a rule, okay, does not mean that you have to always apply it. Okay, forcefully don't try to apply what you have studied. Just because you have studied it, it was there in the syllabus, so forcefully you have taken and applied. It's not needed. Okay, sometimes it is always convenient in GATE to get a good rank. You have to little bit think outside the box and use some basics. Okay, the basic idea over here is, if you will try to use block diagram reduction, it will unnecessarily get complicated. Instead, let us use one technique that I will teach you that will always make you get a very good correct output in block diagram. If it is small block diagram, you don't have to apply block diagram reduction, directly apply this technique. Okay, this is particular to our institution, so stay tuned and watch it very carefully. It will help you throughout and in any situation that you are in. Alright, so before I start my technique, I would like to mark this particular signal as E. Okay, so what I'm going to do, this is a type of signal traversal or first principles method. Okay, so what I'm going to do right now is, at each node I'm going to write the equation what is available and eventually compute y by r. Alright, what I mean by that is, see, at this particular point I'm getting the signal y. Okay, so I have written y. Here my e is getting multiplied into 1 by s plus 1 and it is getting subtracted over here from y. So what should be the signal over here? Here the signal should be y minus e upon s plus 1. Naturally, right? Since this is the signal over here, this is again coming over here and r is coming over here. Now let us write a little bit more better there. What should be the equation? Okay, now I'm going to write the equation for e in terms of the feedback signal that is coming and r. Okay, so what will be my e? I will just do a small partition over here. Okay, my e over here is nothing but r minus basically this entire feedback signal that is there, y minus e by s plus 1. So that is y minus e by s plus 1. Okay, very simple. Okay, there is nothing, no challenge whatsoever so far. Once again, basically what has happened, I just want y by r. I want to eliminate e. I don't want to have any sort of e and all of it. So let me try to write e and y. There should be some relationship. As it is visible, what is happening, since your y is over here, e is over here, e is multiplied into s plus 1 and you are getting y. So what will be the other equation I have? Y is equal to e upon s plus 1. Y is e upon s plus 1, r is like this. Okay, so now just let us have a small observation. If you were to put e upon s plus 1 instead of y over here, what is happening? Both of them are getting cancelled. The moment both of them get cancelled, you are getting e equals r from these two relationships. So combining these two relationships, what I am getting? I am getting e equals r. Because I am getting e equals r, this same relationship I can put here, right? So what I will have, y equals r by s plus 1. Again, what you want? Y upon r, put this r down. So y by r equals 1 upon s plus 1, which is nothing but the final answer. Right? Very simple. Okay, so do not unnecessarily, just because you know a rule does not mean that you have to apply it in solving the problem. Sometimes it is better to use some very basic principles like this, okay, to solve the problem. And as you will see even in my theory classes, I will teach you such verification and shortcut techniques throughout. Okay, so stay tuned for that and let us see another problem now. All right. So this question, the third question, is somewhat very interesting because many students have sent this to me, and apparently this was one of the questions that actually created a lot of controversy also. So I decided to take this question. It looks very simple. It's a very simple question also, but people usually get confused because of some reasons that are there. So what are the reasons? I will tell you. What happens when this is unity feedback? Okay, there are some standard formulas that you remember for Kp, Kv, Ka, and you will try to use that. Okay, but unfortunately those are not applicable when you have a feedback gain, like in this case, right? So what many other people do is, since you cannot use it in this case, they will try to adjust that formula itself to fit to this. Okay, first of all, those formulas are a special case of unity feedback. Over that, now with those special case formulas, you are trying to adjust and make them even more special. Now what will happen to the students? They are busy by hearting two sets of formulas now. One for unity feedback and one when feedback is not unity. And they are creating more mess. Alright. So instead of all of that, I don't believe in all of it because I am currently pursuing a second degree in control. Even till today I have not felt those formulas, those adjusted formulas easy to remember. So I am very sure that you who are preparing for GATE, who have a lot of other subjects, will definitely not like it. Okay. So I have one very easier method, a shorter method to do it. Okay. It's using basic mathematics itself. Just the flow of block diagram we'll use and try to solve it. Okay. So once again, you are having the error as done in the previous question. E is there. I will try to write E in terms of R and C, and then I will try to use final value theorem accordingly. Okay, so very quickly let me start. I will write the first set of questions over here, first set of equations over here. So if you'll see very carefully, basically I want to write the equation for E. So E equals R minus, okay, C is multiplied into this gain, so 2C by S plus 1. Okay, very simple. Once again, what is my C? What is the other equation I have from this block diagram? C is nothing but 3 by S plus 2 into E. Alright, because of that I can write this over here, C equals 3E by S plus 2. Once I get these two equations, what I have to do compulsorily is I have to substitute. I don't know anything in C. I want basically what has happened. Look at the question. Unit step input has been given. So I have input information. I don't have any output information. Because I don't have any output information, substitute this C, whatever you have got this C over here, and let us get another equation which I'll be writing over there. So you can just have a look. That is nothing but E equals R minus 6. Okay, then you have an E divided by S plus 1 into S plus 2. Okay, nothing complicated so far, very simple. Just I have just substituted this over there. Right, shift it and try to flip it. Let us get E in terms of R. In the sense, E will be here and all the remaining things will be on this side. So what will happen? Let us very quickly see. So E, just one more step I will do. So just to show. Okay, so S plus 2, I have plus 6 divided by S plus 1, S plus 2, okay, and I have an R, okay. Now for all this is in Laplace domain, okay, so my R is unit step, I have told you in time domain, so R should be 1 over S, right, and all of this will get flipped. So what will I get? I will get my E to be something like this. So I have 1 by S, so obviously I'll get S plus 1, S plus 2 upon S into this 1 by S has come because of R. So you have S plus 1, S plus 2 plus 6. Okay. Now I will not use KP, KV, all the concepts I have bypassed. All I have to do now is I want steady state value of this. I will use final value theorem. What is that? Final value of E is nothing but limit S tending to 0, S into E of S. Very simple. So I will write that here very quickly. Limit S tending to 0, S into E is basically what I want to find. So if I will try to do that over here, what I will get, my S and S will get eliminated, okay. This S and this S will get cancelled. I am putting 0. So numerator will be 1 into 2, denominator will be 1 into 2 plus 6. So 2 divided by 8. So I am getting 2 upon 8, which is nothing but 1 by 4. So basically if I want to get the error for this particular block diagram, I have done using first principles method where you will never go wrong, and that answer I am getting as 1 upon 4. Alright. So please look, stay tuned and to the next set of questions that are there. Such interesting questions follow. Now the next question is on steady state error analysis, similar to the previous one but a little different. That variation is that here they have given you a closed loop transfer function. Okay, this expression is that of a closed loop transfer function. As to why I handpicked this question, I will tell you. Because this is in the generic form, many people will just look at this question and get worried and they will not try to attempt this. One. Second, there are many chances of making an error. If you are not quite observant, it is very easy to commit an error. What you are supposed to observe, what are the things that are essential, I will tell you now. Okay, so this particular question, consider this expression. Okay, read the question very carefully. It says unity negative feedback. The moment you get such a thing in the question, understand that you can apply all the formulas for KP, KV and KA. The moment you get this particular thing in the exam, please write the formula based on what error they are asking you. What I mean by that is, see, they are asking you steady state error for unit ramp input. Okay, for unit ramp what will it be? It has to be compulsorily, it has to be KV, and I have to write an expression for KV. So let me write an expression for KV in the formula manner. Okay, so let me just write it over here. So my KV is nothing but limit S tending to 0, S into G of S. Alright, now because this is like this, my first priority is I need to find out G of S. Right, if I find G of S, rest all is very simple, because obviously my ESS is nothing but 1 upon KV. Okay, the moment I find this, my problem is solved. Okay, to find that, consider this entire transfer function. Okay, if you consider this transfer function, what will happen is like this. Let me just rewrite this transfer function over here. Please observe. So my TS, which is my transfer function, is an minus 1 s plus an whole thing divided by s power n plus a1 s power n minus 1 plus so on plus an minus 1s plus an. What you can observe, everybody, is that, see, the numerator is having this portion and the same thing has been repeated over here. Right? Why is that essential? Is because it's unity negative feedback, which means h is equal to 1 and the transfer function of the system is of the form g by 1 plus g, and I have to get that in that particular form. Because the numerator is having this portion and this is repeated even here also, all I have to do is I have to take the rest of the function and divide the numerator and denominator, and that whatever residual function you are getting, that is nothing but your g. So to do that, let me do one more step over here. Okay, very simple. All of this things, actually GATE will always ask you such questions which are very simple but they look very complicated, just to intimidate you. Alright, so what I have to divide it by? The rest of the things. So because this term is an minus 1s, the one term before that is an minus 2s squared. Okay, so I have to divide that particular function throughout. So let me just write that. What am I having? S power n plus a1 s power n minus 1 plus so on, plus up to where? an minus 2s squared. Alright, so whole thing divided by 1 plus, okay, because this is the same thing that will be repeated here. Let me just write this as numerator polynomial. Numerator polynomial. Okay, the same thing is repeated. Okay, now this is nothing but my g. Now because this is my g, what I have to do? I have to take limit s tending to 0 s into g. Okay, so if I will do that, that is nothing but my kv, that is nothing but limit s tending to 0 s into g, which is nothing but s into this entire thing. You see, I can remove s square common from the denominator, so I will remove my s square. Okay, and what is the rest you are having? S to the power n minus 2 plus a1 s to the power n minus 3 plus so on. Okay, so I don't have to write the rest. Okay, because it's very much understood. Numerator, I will just copy that as however it is. Okay, so now the moment I will apply the limit, okay, so I have to apply limit over here. Okay, s tending to 0. The moment I do that, I will get infinity as the answer. The moment I get this as infinity, what happens is my error is the reciprocal of infinity, which is nothing but 0. So that will be my final answer. So for this, my final answer will be nothing but 0. Alright, so now let us move on to the next question.